Hello, good afternoon. My name is Siddharth Ajay Sharma and I am doing the Almabetter course of full stack web development. In this course I have cleared my first module while submitting my project, and I am going to explain the third module questions. The third module is design and analysis of algorithm. In this module, one project is there named as design and analysis of algorithm. So to do this project, the project requirement is I have to explain any 5 questions out of 25 coding challenges question and submit a project explanation video in YouTube. So this module has the 25 questions, which includes code bug fixing of 5 question of code bug fixing, and 5 question of enhanced version, and 5 question of question solving, and etc. And these out of 25 question I have to explain 5 questions and maintain a GitHub gist for those all the questions. So for explaining all the questions, I choose the first one, which is the power of 2 puzzle. So the first question I am going to explain is the power of 2 puzzle. In this question, one input is given and I have to calculate that if the given number is the power of 2 or not. So calculate that is the number is power of 2 or not. I have to logically add the power the number given in the input and one subtracted value of that input. So the number of the input number is 16 and I have to logically AND with 15. So if both logically AND gives me 0, then the given input is the valid power of 2. So the question solved by is power of 2 function. Here it checks if n is greater than 0. If n is greater than 0, then this another line of code will be executed. If this is not true, then this line can't be considered. So if the number is greater than 0, it logically ANDs the input and one decremented value, so that it gives 0. If it gives 0, then it is the valid power of 2. So that's the first question. And now going to the second question. To explain second question, I have chooses the minimum moves for valid parenthesis. In this question, I have to calculate how many parentheses it would require to complete all the parentheses validly. So to do this question, I have written a function here, min add to make valid. Min add to make valid has 2 variable initialized as open equals to 0 and close equals to 0, and one for loop is iterating through all the string presented in the input. So if this for loop checks each character of the string. If the character is open parenthesis, then it increases the open variable to 1. Else if open is greater than 0, it decreases the open to 1, and both the condition is not true, then it goes to the else condition, where if the character is close parenthesis. If the character is close parenthesis, the close variable is increases to 1. So in last, we are returning the addition of close and open variable, so that it calculates how much parenthesis it would require to complete the parenthesis present in the string. This is the second question. And going to the third question, I have chosen the third question to explain is shopkeeper's unconventional challenge. In these challenges, one input is given as array, and in this array some numbers given, and C, D and plus, these are the operations. If C occurs in the array, we have to remove the last score and if C occurs in the string, we have to remove the last element from the array. If D occurs in this string, we have to double the last element of the array and append to the array. If plus is the string, then we have to add previous and after previous elements and record to the array. So the approach to solve this problem is, I used here call point function and a for loop which iterates through the array operation array. So if statement checks, the one statement checking the icon plus, and one statement checking the symbol D, and one statement is checking the symbol C. If these three if these three symbols occurs, then it will perform the operations of to the array. And else if these three operation will not true, then it will print only the array and append and convert the string array to the number array. Now the resultant array is stored in operation I. The resultant array is stored in the operation array. So we initialize total sum variable as 0, and we are iterating through the operation array one more time. So it and for this for loop does that all the sum of the array elements and returns to the function as total sum. So this is the third question from the group of analyzing traditional versus optimized approach. So this is the second question of analyzing traditional versus optimized approach. The question says remove duplicate letters. The input is given with duplicate values Z, V, V, O. So I have to return the non-duplicate values present of this character. So I have to remove Z, I have to remove V, one V, then I will return the output as a string. So the resultant output will not contain any duplicate values. So to solve this problem, we have two ways: traditional ways and optimized ways. So I am going to explain you the traditional ways and what is the far better optimized approach. So to overcome these challenges, I have explaining you the traditional approach. In traditional approach, the duplicate check function is given. It takes input as a string, and in temp variable we initialize the first character of the string, and this for loop go through the all over the strings, and it checks for each character. The temp variable is assigned as a first character of the str string. Suppose this is Z. So this for loop go through all over the string characters. So it first of all it checks if the present character is Z or not. If the present character is Z, or the character are already in the temp variable, then it cannot go through this statement. It skip this statement and return temp. If any of the character not present in the temp variable, then it will go through this statement. This statement adds the unique character to the string, and lastly we are returning the temp variable which is non-duplicate. So going to the optimal approach, we take duplicate check function and passing string as an argument, and this in this function we have taken. In the optimal approach, duplicate check function takes string as an argument, and P is initialized as a set. The set has a property that one set cannot have many duplicate values or one single duplicate value. If any single duplicate value present in the set automatically removes that value and store only unique values. So here the optimal approach uses P as a set, and T variable converts the t variable converts the set into arrays using spread operator, and we returning the array as a string with t dot join method. So this is the optimal approach. In optimal approach, the code is more readable, and optimal approach the code is more readable than the traditional approach. And traditional approach using for loop, which is big of an complexity, and here the set object reduces the time complexity and space complexity also. So this is my fourth question, and now going to explain the fifth question. For explaining the fifth question, I have taken the question from logic building and coding questions group. The first question of logic building and coding question is peak elements. In this question, we have to return an number of index of number which is strictly greater than its neighbor. In this array, the value is 3, which is 3 is the number which is strictly greater than 2 and 1, and we have to return the index of this 3, which is 2. So to solve this approach, we have given constraints of nums.length is greater than 1 and less than 1000. So considering these all the constraints, there is given hint. So hint is, since the goal is to find peak element in array with logarithmic time complexity, consider using binary search. So in hint, the binary search is explained. So I have to solve this question using binary search. So for solving this question, we have taken find peak element function and nums of array as an argument. First variable are initialized as 0, and last is the last index of the variable, last index of the array length, which is the length of the array minus 1. And these all codes is the binary search algorithm, and the binary search algorithm has the time complexity of log n. So the binary search algorithm is always the better choice for searching any number. So to do and find peak element, we have given while loop. This while loop runs when while this function is true. The first is the zeroth and the last is the length of the array minus 1. So mid variable is assigned, which divides the array into two halves and starts the mid variable to the mid of the array. So if the if statement checks that the mid element is less than its next number or not. If it's true, the first variable is assigned as mid plus 1, and if this statement is not going to true, then it goes to else statement, and this statement assigned the mid value to the last variable, and after all we are returning the first as an index of the peak element. So this is the fifth question. So this is the explanation of 5 questions out of 25 questions. So this is all about the module 3 project, which is capstone project, design and analysis of algorithms. I have successfully explained all the 5 questions out of 25 questions and maintain a gist repository of that question and answers. Thank you for listening.